For the primary tensioning of V, poly V and flat belt drives, there are the Type MB motor bases where the drive motor of the friction belt drive is mounted directly on the elastic Rosta tensioning element. In addition to automatic tension adjustment, this variant also offers more careful handling of the belt and a gentle run up and run down. Primary tensioning of belt drives with the Rosta motor base. The MB automatic motor base with the installation of the motor directly onto the base offers the continuous compensation of the belt elongation and the advantage of a smooth run-up, resulting a gentle treatment of the belts. When placing large inertial masses in operation, like flywheels, the elastic motor base favors a short-term belt slippage, but immediately develops the necessary tensioning force again. This characteristic can lead to a 5-fold improvement of the belt life. Rosta motor bases Type MB50 by 400 at the drives of wheat roller mills. For extremely long belt drives, like in this application, with a center distance of 2.5 meters between the pulley shafts, the retensioning maintenance service was very costly due to the weekly required readjustment of the motors. The Rosta motor base, with its automatic slack compensation, requires hardly any maintenance. Circular motion gravel screen with rigid motor mounting. The belts have to be retensioned periodically. In running out, the dynamic load is fully hanging in the belts. This excessive stretching is shortening their life. Installation guidelines. The new galvanized MB38 with the individually adjustable motor support for frame sizes 132S to 160L. The elastic motor tensioning unit is held in a U-shaped frame and the support plate is provided with the holes for 4 frame sizes. The core of the device is a Rosta element type DR38 by 300. The inner square of the rubber suspension element is pretensioned by means of a fine thread spindle. The torsion spring transfers the tensioning force to the motor and to the drive pulley. The motor support plate, which is secured with brackets, can then be easily adjusted to the belt track. Positioning of the motor. After fastening the U-frame to the screen structure, the motor is placed on the support plate and temporarily bolted. Setting the belt pulley alignment. Using a straight edge, the parallel alignment of the drive and driven pulley is checked. The position of the motor is correspondingly shifted and the motor is then firmly screwed to the structure. Mounting the belts. The drive motor can be raised by simply turning the pretensioning spindle. The belt set is then placed over the two V-belt pulleys. And to finish off, the belts are then slightly pre-tensioned. Tensioning and test procedure. The belts are loosely laid into the V-belt pulleys. The tension necessary for the transmission of the torque is created by turning the horizontal spindle. The pre-tensioning force must be set up precisely, corresponding to the informations provided by the belt manufacturer using test instruments. This is an important procedure. Securing the position. After setting up the required pretensioning torque, the position of the motor base is secured by tightening the through bolt of the element. Running the screen with elastic motor base. When running the screen up and down, or when running through the resonant frequency of the suspensions, the motor base will swivel out the excessive oscillation amplitudes that arise and thereby save the drive belts from overloads. The effective belt life will increase several times.